Students, let us discuss today the types of vector equation of a line and a plane. The first of all, there are two types of vector equation of lines. One is the vector equation of a line passing through one point and parallel to one vector is given by R bar is equal to A bar plus SB bar. The second vector equation of line is R bar is equal to 1 minus S into A bar plus SB bar. The vector equation of a line passing through 2 points A bar and B bar is given by R bar is equal to 1 minus S into A bar plus SB bar, where S and T are the scalars. Note 1. The vector equation of a straight line passing through the point A bar and parallel to vector B bar is R bar is equal to A bar plus SB bar, where S is a scalar. Right. So, the very first theorem is the vector equation of a straight line passing through the point A bar and parallel to the vector B bar is R bar is equal to A bar plus SB bar, where S belongs to R. S is a scalar. Now look here, point A bar means it's a position vector of a point A, and the line is parallel to what vector? B bar. Yes, if I take this is A or else O, you take an initial point passing through the point A bar. This is, now if I take this in as or else P of R bar, you take this is what? This is AP bar. So if I take this as like this is also B bar. This direction is AP bar. This direction is like this. This is AP bar. Now, here A bar is a position vector of a point A, and P of R bar is an unknown that we are naming it as what? Straight line. If you take in terms of geometry, what's the equation of straight line in a general form? AX plus BY plus C is equal to 0. If we have a first degree terms X and Y, then only we represent it as what? Straight lines. So therefore, any first degree equation always represents straight lines. That is, in terms of Cartesian coordinate system, in terms of vector algebra, vector notation, R bar represents a general point or a general vector which represents an equation of a straight line. Some name we have to make it. That name is nothing but what? R bar. So therefore, A of A bar, the line is passing to the point A bar. You can take in the direction or in this direction as you please. This is P of R bar. For this line AP bar, B bar is a vector parallel to it. B bar is a vector parallel to it. Let us see how. let OA bar is equal to A bar, OP bar is equal to R bar, be the previous position vectors of the points A comma P. Let B bar be the vector parallel to AP bar. As you know by the definition, when any two vectors are said to be either collinear or parallel, one vector can be expressed as scalar multiple of another vector. Means there exists scalar. So therefore there exists a scalar. Whatever the scalar you have taken, you can take it scalar. Yes, such that one vector can be expressed as scalar multiple of another vector. So therefore such that one vector expressed as S into scalar multiple of another vector. So therefore now why you are not writing B bar is equal to S into AP bar? AP bar is not given. Its position vectors are given. B bar is a vector. AP bar vector is not given. Its position vectors are given. I mean OA bar, OP bar are given. So therefore P bar, that is P, is a general point, unknown, that we are supposed to find out in terms of R bar is equal to A bar plus SB bar. For that reason, student must be aware of what? You should not write B bar is equal to S into AP bar. You have to write what? AP bar is equal to S into B bar. You should not make the scalar multiple as unknown point or unknown vector. So therefore, AP bar, I can write, yes, come on, OP minus OA is equal to S into B bar. B bar is a vector. Its position vector are given. The position vectors of its extremities. The position vector of terminal point minus position vector of initial point. Therefore, what is OP bar? OP bar is given by R bar minus A bar is equal to SB bar. So therefore, now I can write this one as R bar is equal to A bar plus SB bar. This represents the vector equation of a straight line passing through the point A bar and parallel to vector B bar is given by R bar is equal to A bar plus SB bar. R bar is equal to A bar plus SB bar. So therefore, now once again, let OA bar is equal to A bar, OP bar is equal to R bar be the position vectors of the points A comma P respectively. Now let B bar be the vector parallel to what? AP bar. There exists scalar S such that AP bar is equal to S into B bar. So therefore, now I can write AP bar is not given, its position vectors are given. Therefore, OP minus OA is equal to S into B bar. Now this is R bar minus A bar is equal to SB bar. So therefore, R bar is equal to A bar plus SB bar, where S is a scalar, where S belongs to what? R. Yes, students, now we came to know that the vector equation of a straight line passing through the point A bar and parallel to vector B bar. Now I want to find out its Cartesian forms. Means in terms of x, y, z, we are supposed to find out. Now, theorem. The equation of line passing through the point A of A bar, where A bar is equal to A1i plus A2j plus A3k, and parallel to the vector B bar. Now this is nothing but B1i or else B1i plus B2j B3k in the Cartesian form. Cartesian form is x minus a1 by b1, y minus a2 by b2, z minus a3 by b3 is equal to s. Now, if you want to find out the equation of the line passing through the point A bar and a parallel to vector B bar, where B bar is equal to B1i plus B2j plus B3k. Now, what's a pictorial representation? This is A of A bar and P of R bar. This is AP bar. This is parallel to B bar. Right. So now, proof of this is, now I can write O. If you want, you can take O is a free vector, R is incorrect. This is OA bar, OP bar. B bar is a vector, no need to go with O. Let it is OA bar is equal to A bar is equal to A1, A2, A3. OP bar is equal to R bar is equal to xi plus yj plus zk. I can also write in the form of what? Order triple. So therefore, be the position vectors of capital A comma P, and B bar is equal to B1, comma B2, comma B3, be the vector parallel to the line, AP bar. Now we know that the vector equation of line, passing through the point A of A bar and parallel to vector B bar is R bar is equal to A bar plus SB bar, where S is any scalar. I can write this one as R bar minus A bar is equal to SB bar. This can be written as, what is R bar? This is Xi, Yj, Zk minus A1i, A2j, A3k is equal to S into B1i, B2j, B3k. Now group the like terms. X minus A1 into I, Y minus A2 into Z, Z minus A3 into K is equal to S into B1I, B2Z. Equate the like terms, equate the coefficients of like terms. So therefore, now if I compare equating by equating, now by equating, which implies X minus S into B1, Y minus A2 is equal to S into what? B2, Z minus A3 is equal to S into B3. S into B3. Yes, we got it. X minus A1 is equal to S into B1. Y minus A2 is equal to S into B2. Z minus A3 is equal to S into B3. S into B3. So therefore, X minus A1 by B1, Y minus A2 by B2 is equal to S, Z minus A3 by B3 is equal to S. Now which implies I can write X minus A1 by B1, Y minus A2 by B2, Z minus A3 by B3 is equal to S. These are known as Cartesian forms of a straight line passing through the point A bar, where A bar is equal to A1i plus A2j plus A3k, and parallel to the vector B bar is equal to B1i plus B2j plus B3k. Yes, students, now we have come across, we discussed two types of vector equations, two types of equations of lines. One is a vector equation of a straight line. The second one is the Cartesian form of a straight line. The Cartesian form means which comprises in terms of x, y, z. But whereas in vectors, you'll be having R bar is equal to A bar plus SB bar. That represents a vector equation of a straight passing through the point A bar and a parallel to vector B bar. This represents a Cartesian equation of a straight line passing through the point A bar, A1, A2, A3, parallel to the vector B bar is equal to B1, B2, B3. Yes, once again, the same forms we use in the what? 3D straight lines. The student feel is if you know the what this concept in the what 3D straight lines, very easy to understand. So therefore, hereafter, the vector equation of a straight line passing through the point A bar parallel to vector B bar is R bar is equal to A bar plus SB bar. The Cartesian form of a straight line is x minus A1 by B1, y minus A2 by B2, z minus A3 by what? B3. Yes, today we come across about the vector equation of a straight line passing through the point A bar and parallel to vector B bar. Let us take one example on this. Students, to have a clarity, because this vector equation of a straight lines and planes plays a vital role in the multiple product of vectors. You have much applications, that too geometrical applications. This all comes under the geometrical applications. So therefore, one must concentrate very well on this. So now I want to find out, with the application of what vector equation of a straight line passing through the point A bar and a parallel to vector B bar, I want to find out the position vector of a point B. How? A line passing through the point A of 3i plus j plus k, this position vector, and parallel to the vector 2i minus j plus 2k. Sometimes they give the vector, sometimes give directly that one. If P is a point such that AP is equal to 15, P is a point such that means P is a point on the line AP, its magnitude is given, then we are supposed to find out the position vector of a point P. Now if I take, now for this one is, the solution of this is, if I select this is A of A bar, so P of R bar, this is, but this length is given what? 15. This is the vector B bar is equal to s command 2i minus j plus 2k. Yes, given. With reference to this data, I am supposed to find out the position vector of a point P. The position vector of a point P. Let us discuss about how we have to find out. Yes, we know that the vector equation of a line passing through the point A of A bar and parallel to B bar is AP bar is equal to S into B bar. I take this a 1. Now take the modulus on both sides is equal to S into modulus of B bar. You are nothing to do with the what modulus for a scalar. Now, modulus of AP bar is equal to how much? 15. S into, what is modulus of B bar? Modulus of B bar is square root of, yes, what is B bar? Now this is modulus of B bar. Now I can write this is 4. This is plus 1. This is what? Plus 4. Which implies plus r minus 15 is equal to 3s. Therefore, this get cancels. S is equal to plus r minus 5. Now, case 1, let us see how this is. Case 1, if S is equal to plus 5, 1 implies AP bar is equal to 5 into B bar. This is OP minus OA. Now this is equal to 5 into B bar. OP bar is equal to OA bar plus 5 into B bar. Therefore, OP bar is equal to, what is OA bar? OA bar is equal to 3i plus j plus k. This is nothing but 3i plus j plus k plus 5 into b bar. 5 into b bar, this is 5 into, I can write 2i minus j plus 2k. So therefore, OP bar is equal to 3i plus 10, this is 13i. Now plus j minus 5j minus 4j plus k, this is 11k. This is the position vector of a point P when S is equal to what? 5. So therefore, the another case comes, case 2. What is case 2? If S is equal to minus 5, S is equal to minus 5. When S is equal to minus 5, S is equal to minus 5, now what is position vector of this one is? Now one implies, yes, AP bar is equal to minus 5 into B bar. So therefore, OP minus OA is equal to minus 5 into, okay, B bar. Okay, let it be. You can take this one as what? B bar, right? B bar. So therefore, OP is equal to OA bar plus 5B bar. I can write 3i plus j plus k plus, that is minus 5. Here, instead of plus, we have to take it minus. This is minus 5b bar. Therefore, minus 5 into, what is b bar? B bar is nothing but 2i minus j plus 2k. Therefore, OP bar is equal to 3i plus j plus k. Yes. Now, 3 minus 10 minus 7i plus j plus 5j. It becomes what? 6j. Yes, plus k minus 10k minus 9k. Minus 9k. These are the position vectors of the point P under the condition that AP is equal to 15. So therefore, what he has given, a line passing through the point A, that is whose position vector is 3, 1, 1, and parallel to what? 2i minus j plus 2k. If P is a point such that AP is equal to 15, then OP is dash, means what? Position vector of P is dash. What I do is AP bar, it's a passing through the point A, parallel to vector B bar. Now it's a parallel to vector B bar is given, and he has given length of this AP, segment AP. So therefore it's a 15. Under the condition 15, we are supposed to find out the position vector of a point P. Followed? So therefore what I did, we know that the vector equation of a straight line passing through the point A bar and the parallel to vector B bar is AP bar is equal to S into B bar, is nothing but OP minus Y is equal to SB bar, is nothing but R bar is equal to A bar plus SB bar. Its locus is this only. What is that? R bar is equal to A bar plus SB bar. This locus is R bar is equal to A bar plus SB bar. We have to speak about the locus. Instead of writing directly R bar is equal to A bar plus SB bar, I stopped at what? AP bar is equal to SB bar. Why? Its locus can be interpreted at any time. So therefore, AP bar is equal to SB bar. Call it as 1. So therefore, now take the modulus on both sides. Modulus of AP bar is equal to S into B bar. 15 is equal to S into what this? Therefore, S is equal to plus R minus 5. Now, here two cases arises. When S is positive, when S is negative. If S is equal to 5, now AP bar is equal to 5B bar. AP bar is not given, its position vectors are given. It's a OP minus OA is equal to 5B bar. OP bar is equal to OA bar plus 5B bar. Next, OP bar is equal to 3i plus j plus k plus 5 into what? 2i minus j plus 2k. Then OP bar is equal to 13i minus 4j plus 11k. Next, if S is equal to minus 5, this is OP bar is equal to minus 5B bar. Next, OP minus OA. Next, transfer OA. Therefore, OP bar is equal to minus 7I plus 6J minus K is the one position vector. Other one is 13I minus 4J plus 11K is the other position vector. Followed? This is all about the application and the theoretical part of first one, the vector equation of a straight line passing through the point A bar and the parallel to vector what? B bar. That is, R bar is equal to A bar plus SB bar. And also we come across about its Cartesian equation of a line, that is x minus A1 by B1, y minus A2 by B2, x minus A1 by A1 is equal to y minus A2 by B2 is equal to z minus A3 by B3 is equal to what? Yes, those are called Cartesian forms or a Cartesian equation of a straight line passing through the point A bar and the parallel to vector B bar. Followed? Yes. Next, we shall try to understand what is that? The vector equation of a straight line passing through 2 points there, A bar and B bar. A bar and B bar. Let us discuss about the second type of vector equation of a straight line in the form of R bar is equal to 1 minus S into A bar plus SB bar. Vector the vector equation of a straight line, the vector equation of a straight line passing through the points capital A of A bar, B of B bar is R bar is equal to 1 minus S into A bar SB bar, where S is a scalar. R bar is equal to 1 minus S into A bar plus SB bar represents a vector equation of straight line passing the 2 points. They are A comma B whose position vectors are A bar comma B bar. Let us see. If I take this is A of A bar, this is B of B bar, this is P of R bar. So why third point? Why to name it? It's a line equation, we have to name it. So without X and Y, it is not a straight line. Without R bar, it's not a straight line. Now if I take this what origin for position vectors, OA bar, OB bar, OP bar. Now this is B bar, this is A bar, this is what? R bar. Now OA bar, OB bar, OP bar represents the position vectors of its extremities. Position vectors of its extremities. Now, when 2 points are given, third point you have to take it as a what? Representing a line equation to name it. It's a general point. General point represents a line equation. So now, if I take this as proof of this one is, let OA bar is equal to A bar, OB bar is equal to B bar, and OP bar is equal to R bar be the position vectors PVS, position vectors PVS of capital A, comma B and P respectively. Respectively. Now from figure, you can very well observe the points A, comma B, comma P are lying on a same line. Then they are collinear. When they are collinear from 3 points, we can make it 2 vectors. One vector can be expressed as scalar multiple of another vector. So therefore from figure, what I can write is, from figure, the vectors, from figure, the points capital A, comma B, comma P are lying on the same line. Which implies AB bar, comma AP bar are collinear. Why? A, comma B, comma P are also collinear. The vectors formed by them are also collinear. Now, when they are collinear, there exists a scalar, yes, such that one vector can be expressed as scalar multiple of another vector. Now, are you given with a vector AP bar? No, we are not given with a vector AP bar, AB bar, but the position vectors of AP bar and AB bar are given. That is, OA bar, OB bar, OP bar is given. So therefore, what I do is, now this vector can be expressed as position vectors of its extremities is equal to S into OB minus OA, OB minus OA, OB minus OA. Now look here, we are given with, this is R bar minus A bar, S into B bar minus A bar. So therefore, now R bar is equal to, yes, come on, 1 minus S into A bar plus SB bar, where S belongs to R. You can very well observe, this is the what? The vector equation of a straight line passing through the point A bar, passing through the points A bar and B bar. Here it is passing the 2 points. Passing through how many points? 2 points. Okay. So therefore, now what I can write is, so therefore, R bar is equal to 1 minus S into A bar plus SB bar, where S belongs to what? R. S belongs to R. So now once again, let OA bar is equal to A bar, OB bar is equal to B bar, OP bar is equal to R bar. P is a general point on the what line. So therefore, be the position vectors of capital A, comma B and P respectively. From figure, you can very well observe the points A, B, P are lying on the same line. Means what they are? Collinear, which implies the vectors followed by them. Them means what? The collinear points are also what? Tell me, collinear. So therefore, AB bar, AP bar with the 3 points, 2 vectors you can form. Therefore, AB bar, AP bar are collinear. Now there exists scalar S such that one vector can be expressed as scalar multiple of another vector. So therefore, now AP bar is not given, its position vectors are given, OP minus OA, S into OB minus OA. Now OP bar is equal to R bar, OA bar is equal to A bar, OB bar is equal to B bar, OA bar is equal to A bar. So therefore, R bar is equal to 1 minus S into A bar plus SB bar represents what? The vector equation of a straight line passing through how many points? 2 points, A bar and B bar. A bar and B bar. Followed? Right. Now let us see this. What is the concept of this one is? He asks the problems how this is. It is. He asks one example. The vector equation of a line passing through the points 1, 4, 5, 2, 8, 10 is dash. So now he has given 2 points. Then how do you do it? This one is simple. Very simple problem this is. Let OA bar is equal to A bar is equal to 1, 4, 5 and OB bar is equal to B bar is equal to 2, 8, 10. Just you substitute the vector equation of a line passing through the points A of A bar, B of B bar is R bar is equal to 1 minus S into A bar plus SB bar. 1 minus S into A bar. Just take these 2 points, you substitute. R bar is equal to 1 minus S into I plus 4j plus 5k plus S into 2i 8j 10k. This represents about the vector equation of a straight line passing through how many points? 2 points, A bar and B bar. Remember. So you must be very careful about R bar, the vector equation of straight line passing through 1 point parallel to one vector. This is passing through how many points? 2 points. But in some problems we use both, because both are also what? Straight lines. Both are also vector equation of straight lines. I give some examples, some applications, how to make use of. Both are same only. But it depends upon how the option is given, because options are nothing but indirectly prove that and show that. So therefore depends upon the questionnaire, how the options are framed out. Depends upon the options which one we have to use. Whether we have to use R bar is equal to A bar plus SB bar, means that represents a vector equation of a straight line passing through the point A bar parallel to vector B bar, that is R bar is equal to A bar plus SB bar, or depend upon the what options how he has given on the what vector equation of a straight line passing through 2 points A bar and B bar is what R bar is equal to 1 minus S into A bar plus SB bar. You can use any one, but depends upon the requirement, depends upon the want of the solution. We can make use either R bar is equal to A bar plus SB bar, or R bar is equal to 1 minus S into A bar plus SB bar. Okay. Now, next we shall discuss about the Cartesian form, that the Cartesian equation of a straight line passing through how many points A bar and B bar.